only it's all in terms of x. There's a y on one side, but then everybody else is x. So I've actually separated the variables by doing this process. Okay, so I know it's a complicated process. You'll see today when we practice it, it's not as complicated as the derivation looks. But this is the formula that we're going to be working with today. So this is important thing number 3. And it makes use of parts 1 and 2. Because part 1 and 2 was standard form. This was, can you find q of x? Can you find p of x? And this here is the integrating factor, which we said was an important thing to know, number 2. Oops, and of course this should be part of important thing to know, number 1. Okay, so if we can find the pieces, we can set it up in this integral. And I'll tell you right now, it looks awful and horrible, but again, the textbook is going to pick examples that work out nicely. So when we look at them today, that's what's going to happen. So I think it's best that we probably try an example to see how this fits together. So let's see if we can unscarify. Is that a word?
No.
No? Yes, maybe? Okay, don't use that on your SAT score for vocab stuff, okay? But let's try and unscarify this a little bit. So first of all, we have to ask ourselves about standard form. Okay, that was number 1 for doing this kind of equation. Is this in standard form right now? It's okay if you need to look back at your notes and see what standard form is. Does this fit the pattern for standard form? Yes, that is correct. So, if you don't quite recognize it, this is one way that I could write it. And this matches up to the notes a bit better. Right here, that's p of x. Right here, that's q of x. Okay, so that's step number 1, is we recognize the pieces from standard form. Okay, so we said the second one was to find the integrating factor. So the integrating factor is this funny looking exponential of 1 dx. So if I integrate 1 dx, what do I end up getting? X, yeah. So this is going to be e to the x. Okay, so now I have all my pieces. Pieces are done. That was part 2. Okay, so pieces are all there. Now we have to arrange this in the form that we had, which was 1 over the integrating factor, which is e to the x, times the integral of q of x, so it's going to be e to the x, times the integrating factor, which is again e to the x. Okay. So now we can actually come up with the answer to this. And one thing just to keep in mind is these things are actually separate. When you're dealing with functions, you can't just pull functions out of the integral, right? You can't just go like this and say, oh, let's pull it out and cancel the e to the x's. It doesn't work that way. There's kind of like there's imaginary brackets here. You can't pull this thing out. First, you have to integrate before you can do anything else. So pretend there's a set of brackets on it until you've, before you simplify anything. Okay, so let's go back to this question. That's going to be 1 over e to the x, the integral of e to the 2x dx. I just see, let's see how we're doing here. How many people can do this integral without substitution? They're confident now you can do this without substitution. Maybe so, sort of. Maybe 30% of us. Okay, I'll do this with substitution then. But let u equal 2x, du equals 2 dx. So that means when I'm working on this one here, it's going to be 1 over e to the x. And I'm missing this 2. So I'm going to put a 1/2 in the front so that I can introduce a 2. So now all the pieces here will line up in terms of u. And that means I would get 1 over e to the x times 1/2 e e to the u du. So that's 1 over 2 e to the x times your favorite derivative and antiderivative. It'll just be e to the u. And remember, there's a constant in there. Okay. So what we need to do now is replace u. That'll be 1 over 2 e to the x and e to the 2x plus c. So obviously the advantage, if you don't have to do substitution, I mean, I've obviously had more practice at it, but starting with the original, I could have found that antiderivative in probably 10 seconds. I just took an extra 30 seconds off of my exam basically to do that. So, you know, it's not that it's going to crush you, but you want that extra time wherever you can find it. Okay, and so we can finish this off. This will be e to the 2x over 2 e to the x plus c over 2 e to the x. So exponent laws here will give me e to the x divided by 2 plus c over 2 e to the x.